Assalamu alaikum and welcome back to the ITV Math show. Now before the break we did a rider. I gave you guys a geometric rider and we needed to solve for x, y, z. It looked a bit hectic towards the end when I gave you all the justification. I'm just going to quickly recap on how we attacked it. Okay, we took a diagram. We said we needed to find the value of x, y and z. So we started with the diameter. We know that the diameter is 90 degrees. It subtends 90 degrees at the circumference, and that was the first statement. Angle CBA. Let's put that as B. CBA is equal to 90 degrees. Why? Angles in a semicircle. Therefore, angle Y, this is a triangle. So angle Y is equal to, we know sum of angles of a triangle add up to how much? 180. So it's 180 minus 90 plus 20. 180 minus 90 plus 20. 180 minus 90 plus 20 is 110. 180 minus 110. Y is equal to 70 degrees. Now, we now needed to get to x. We know that this was 60 degrees. That is a radius. That is a radius. And we know that radii are equal in length. So now, 180 minus, that's an isosceles triangle. Hence, these two angles are equal. If that is x, angle D2 is also x. So therefore, we can say 180 minus 60 divided by 2 to get the value. These two angles are equal. There we go. 180 minus 60, sum of angles of a triangle, divided by 2 because it's isosceles. So 180 minus 60 is 120 divided by 2. X is equal to 60 degrees. And we had y was equal to 70 degrees. We now needed to get to z. We know angles on a straight line add up to 180. So z is equal to 180 minus the 60. Adjacent supplementary. 180 minus 60, z is equal to 120 degrees. Right, so I hope you guys got that one right. Let's now go on to, we're now picking up the pace and we're now going on to example number 2. So this segment as well as the final segment of today's episode will be dealing with riders. We will continue with more complex riders in our next episode. So stay tuned to ITV and keep your dials locked onto channel 347. So example number 2. Take this diagram down. As I am taking it down, I would like you, the viewer, to take it down with me so that you know exactly what you are doing. Okay. Let's draw a diameter there, and we draw another diameter there, and we draw we draw a bow tie. Now, as you are drawing, you are already identifying a theorem. That's why it's always so nice, or it's advisable that you always redraw a shape, because as you are redrawing it, you are already picking up on theorems that you were taught. Already, before the shape is already complete, we already see the bow tie, and we already can identify that certain angles are going to be equal. Okay, and we do that, and we do that. Arrows represent parallel lines. These two are parallel. We've got A, B, P, C, D. We've got O1, O2. We've got this angle to be 140 degrees. B1, B2, that's angle Z. That is Y. That is X. And that is D. Right. They say AC and BD are diameters. AC is a diameter. That means that would imply. Why do they tell you that AC and BD are diameters? Because they want you to use your theorems of diameters, number one. And another reason why they tell you it's a diameter, because it implies that O has got to be the center of the circle. O has got to be the center of a circle, because a diameter is a line which runs through the center of the circle. If it doesn't run through the center of the circle, what is the term that we use? A chord. A chord is a line from one end of a circumference to the other, but doesn't go through the center. A diameter is a line from one end of the circumference to the other end of the circumference of a circle, but must go through the center. So hence, when they tell you that AC and BD are diameters, they are implying that O is the center of the circle. What other information do they give us? They tell us AB is parallel to CD. AB is parallel to CD. By them telling you that, they are already informing you, use your rules of parallel lines in order to, as a tool or as a vehicle to get to your answer. So basically what they tell you in a statement is already giving you a clue. It's pushing you ahead as to what theorems you can use in order to solve your problem. And they tell you that they meet AC and AC meets BD at O. AC meets BD at O. So obviously, again, trying to imply to you that O being the center of the circle. What are we required to find? As you can see, X, Y, Z. X, Y, Z is what we are required to find. Okay? Question says, find X, Y, Z. Now you'll notice that in my handwriting I always put a line through the Z. Some of you might be asking the question, why do I put a line? Because I use it for my own benefit so that I do not confuse it with a 2. So if I had to write the number 2, it could be a 2, it could be a Z. Whenever I write the alphabet Z, I always write as a Z with a line going through it so that I'm able to identify and I don't get confused when working it out. And hopefully I would expect you to do the same in your exams. So find X, Y, Z. Again, let's study the problem first. Let's go through. Start with the knowns, moving to the unknown. Start with my known. Which is my only known? 140 degrees. Which are my unknowns? X, Y, Z. Theorems. Let's study the diagram. What's given? We're given a diameter. Is it subtending any angles? No, not yet. What else do I have? Besides having a diameter, I've got parallel lines, so I know I'll be using alternate angles. What else do I have? I have angles around a point. What else do I have? I've got lines crossing each other, so I've got vertically opposite angles. What other diagram do I have? I've got a big cyclic quadrilateral, A, B, P, C, cyclic, all 4 points. So we know opposite angles of a cyclic quadrilateral are supplementary, or they add up to 180 degrees. So I've got a host of theorems that I can get to my answer.